January 28, 2021, the Foundation Food Group, or FFG, poultry processing plant in Gainesville, Georgia. A single part inside of a liquid nitrogen freezer was bent, causing the freezer to overflow. Liquid nitrogen vaporized once it escaped the freezer, forming a deadly cloud inside of a freezer room. 2 people who were in the room at the time of the release died from asphyxiation. 14 employees attempted to respond to the release. 4 of those workers also died, and 3 were seriously injured.
This preventable tragedy underscores the importance of safety leadership, systems, and training. FFG lacked critical monitoring equipment and alarms. Management did not provide workers with adequate training or equipment to respond safely to a liquid nitrogen release. During this incident, several workers tried to save their colleagues' lives without realizing that nitrogen had displaced oxygen in parts of the plant. While attempting to rescue their colleagues and evacuate, 4 workers lost their lives. In total, 6 workers died in this preventable incident, and 3 other workers and a firefighter were seriously injured.
Foundation Food Group owned 4 poultry processing plants in Gainesville, Georgia. The plant known as Plant 4 housed 5 production lines that made various cooked, partially cooked, and marinated chicken products. On each production line, conveyor belts transferred chicken through equipment such as ovens, fryers, freezers, and baggers. Production line number 4 produced marinated, diced, fully cooked chicken that was then frozen using liquid nitrogen. Nitrogen is not hazardous in and of itself. It makes up about 78% of the air we breathe. However, too much nitrogen can reduce a space's oxygen concentration to unsafe levels. When it vaporizes, liquid nitrogen greatly increases in volume. Just 1 gallon of liquid nitrogen can expand to roughly 700 gallons of nitrogen gas. Therefore, a large spill of liquid nitrogen can quickly vaporize, fill a room, and lower the amount of oxygen available to breathe. If the oxygen concentration is low enough, a human can lose consciousness in as little as 1 or 2 breaths. Prolonged exposure to insufficient oxygen can result in death. At FFG, liquid nitrogen was used on line 4 in an immersion spiral freezer, which was comprised of 2 separate freezers that were connected together. First, a conveyor belt carried chicken into the immersion freezer, where it was partially frozen in a liquid nitrogen bath. Then, the chicken moved through a transition box to the spiral freezer. There, an internal fan was used to circulate vaporized liquid nitrogen around the chicken to complete the freezing process. The immersion spiral freezer was leased to FFG by an industrial gas products company called Messer LLC. Messer installed the freezer on production line 4 in mid-December 2020. But over the next 5 weeks, FFG experienced a series of operational problems with the equipment. Messer returned to Plant 4 on multiple occasions to troubleshoot those issues, which included problems with belt loading, liquid nitrogen level controls, and freezing. But nonetheless, on January 26, 2021, FFG found that the immersion spiral freezer was still having problems. Soft, partially frozen chicken was emerging from the freezer. With Messer's guidance, FFG made several attempts to correct the issue, but 2 days later, the problem persisted. At 8:14 a.m. on January 28th, FFG stopped processing chicken on line 4 so that maintenance personnel could continue to troubleshoot the issue. The maintenance workers, however, did not shut down the freezer as they performed their work. With chicken production on pause, the supervisor instructed the line 4 production workers to take a short break while the maintenance workers inspected the freezer. While the workers were on break, the immersion freezer's bubbler tube somehow was bent. The bubbler tube was a device that measured and controlled the level of liquid nitrogen inside the immersion freezer. The CSB was not able to determine exactly how the bubbler tube became bent, but it was bent in such a way that the end of the tube was above the overflow level of the freezer. This meant the end of the bubbler tube was not in contact with any of the liquid inside the freezer. As a result, the bubbler tube incorrectly reported that there was no liquid level to the immersion freezer's nitrogen level control system. The bubbler tube was the only instrument that sent data to the freezer's nitrogen level control system. Since the freezer was not shut down, its nitrogen level control system reacted to the bubbler tube's improper reading by adding more liquid nitrogen. The freezer was also equipped with a high-level safety interlock that, when activated, was designed to close valves to shut off the flow of additional liquid nitrogen into the freezer. But this safety interlock was also controlled by the bubbler tube, and because the tube could not detect any liquid, the interlock could not activate. Since the bubbler tube was bent above the overflow level of the freezer, it continued to measure no liquid level, even as liquid nitrogen overflowed and escaped the freezer. Once released, the liquid nitrogen vaporized and filled the freezer room with a white, fog-like cloud. After about 20 minutes, at 8:40 a.m., the Line 4 production workers returned from their break. At this time, the workers noticed a cloud of white fog coming from the freezer room. But one of the workers told the CSB that they regularly observed white fog in the freezer room, so they did not believe there was a problem. Therefore, the uncontrolled liquid nitrogen release continued for another hour. Beginning to suspect something was wrong, about 9:40 a.m., a worker crawled through an elevated opening to investigate the freezer room. She saw one of the maintenance workers lying motionless on the ground, as well as a white cloud, approximately 4 feet high, filling the room. The worker reported the incident to management, who initiated an evacuation. But the CSB found that FFG had not trained or prepared its workforce for a release of liquid nitrogen, and workers lacked knowledge of its hazards. Therefore, during the evacuation, at least 14 other FFG employees, including members of management, responded to the incident by either investigating the freezer room or attempting to rescue their co-workers. The 2 maintenance workers were fatally injured by asphyxiation due to the vaporized liquid nitrogen. 4 other FFG employees were also fatally injured as they attempted to respond to the incident. Another 3 FFG employees and a firefighter were seriously injured with asphyxiation symptoms. The CSB launched an investigation and found 5 key safety issues contributed to the severity of the incident at Foundation Food Group. They are single point of failure, atmospheric monitoring and alarm systems, emergency preparedness, process safety management systems, and product stewardship. The first safety issue found by the CSB at FFG is a single point of failure. The CSB learned that the immersion freezer was equipped with a nitrogen level control system. This control system maintained a consistent level of liquid nitrogen within the freezer, and the freezer utilized a high-level safety interlock designed to prevent overflow. But the bubbler tube was the only piece of equipment that sent measurements to both the nitrogen level control system and the high-level safety interlock. Therefore, once the bubbler tube was bent and measured no liquid in the freezer, these 2 pieces of safety equipment were unable to work as intended.
At FFG, the failure of a single component resulted in 6 fatalities. Companies must ensure that processes and equipment handling hazardous chemicals are robust so that one failure does not result in a catastrophic incident.
During its investigation, the CSB found that the team that designed the immersion freezer did not fully consider the consequences of the bubbler tube failing. As a result, the design team did not install any other safeguards that could prevent an overflow should the bubbler tube fail.
Regardless of how the level control system failed, relying upon a single layer of protection to guard against a multiple fatality incident is not sound safety design.
The second safety issue identified by the CSB is a lack of atmospheric monitoring and alarm systems. Once a release occurs, atmospheric monitoring and alarm systems are essential for preventing people from entering unsafe environments. There is abundant industry guidance on the importance of atmospheric monitoring when the potential for hazardous atmospheres exist. The CSB learned that Messer informed FFG of the need for atmospheric monitoring of its liquid nitrogen processes on at least 3 occasions. But the CSB found that neither Messer nor FFG ever installed any atmospheric monitoring equipment in the freezer room where the hazardous release occurred. As a result, many personnel were unaware that the freezer room was unsafe to enter on the day of the incident.
Without atmospheric monitoring, an oxygen-deficient atmosphere cannot be reliably detected. Many of the responding FFG employees likely had no idea they were walking into a hazardous atmosphere. Facilities that handle hazardous gases or cryogenic asphyxiants, like liquid nitrogen, should have a functioning atmospheric monitoring and alarm system based on a properly conducted risk assessment.
The third safety issue found at FFG concerns emergency preparedness. Effective emergency preparedness can reduce the consequences of a catastrophic incident, but the CSB found no evidence that FFG had any formalized policies or procedures for responding to a liquid nitrogen release. The company did not train its employees on how to recognize or respond to such a release, and did not equip them to safely respond. Therefore, when the release occurred, the workers did not understand the danger of entering the freezer room, and they lacked any equipment or PPE that would have enabled safe entry into the freezer room once the incident began. As a result, after the discovery of the first 2 deceased workers, 4 other employees who entered the freezer room also died, and 3 additional employees responded and were seriously injured.
Companies handling hazardous materials have an obligation to train and inform their employees. What made the situation worse at FFG was that many of the company's employees didn't know that the site used liquid nitrogen, didn't know that liquid nitrogen could create a hazardous atmosphere, and didn't know how to respond to a release. Without this knowledge, well-intentioned FFG employees attempted to help their fallen friends and coworkers and were unaware of the life-threatening conditions that led to their injuries and fatalities.
The fourth safety issue found by the CSB is an inadequate process safety management system. The CSB found that FFG had no documented process safety management system to identify, evaluate, and control the hazards of the liquid nitrogen process. In particular, the CSB found that FFG did not evaluate hazards introduced by the freezer process, and the company did not consider how changes to the freezer process could introduce new hazards. As a result, FFG installed the liquid nitrogen freezer in an area particularly susceptible to an oxygen-deficient atmosphere, a mostly enclosed, partially recessed room without mechanical ventilation or atmospheric monitors.
Companies of any size and risk profile can adapt process safety management principles to their operations so that hazards introduced by the process, equipment, and facility are properly identified and controlled. If FFG had implemented key process safety management elements, this incident may have been prevented.
The CSB also found that FFG did not implement important administrative process safety practices. For instance, FFG allowed the position of safety manager to be vacant for more than a year, finally filling the position less than 2 months prior to the incident. And the company lacked written procedures on its freezer operation and maintenance. FFG also did not provide signage communicating the asphyxiation hazards in the freezer room and did not train its workers on the asphyxiation hazards of liquid nitrogen.
Through our interviews, we found that employees at all levels of the organization, including company executives, supervisors, line workers, and even the health and safety manager, reported having limited or no knowledge of the hazards of liquid nitrogen or of its use at the facility. With improper training, non-flammable, non-toxic chemicals such as nitrogen can be incorrectly assumed to be non-hazardous. Companies handling these materials have an obligation to train and inform their employees.
The CSB notes that there is abundant industry guidance concerning the proper handling and safety management of cryogenic asphyxiants like liquid nitrogen. But none of these requirements and guidelines are currently enforceable by regulation. That is because OSHA and the EPA do not define liquid nitrogen as a highly hazardous chemical or extremely hazardous substance. Therefore, neither OSHA's Process Safety Management Standard nor EPA's Risk Management Program rule applies to liquid nitrogen processes. That is the case even though uncontrolled liquid nitrogen releases have resulted in serious injuries and fatalities in several industries.
Food manufacturers are not immune from chemical hazards and process safety risks. When an organization introduces a hazardous chemical into its process, it should implement robust process safety management practices to effectively control the risks, regardless of whether a regulation requires it. If FFG had an effective process safety management system, this incident could have been prevented. But the CSB also believes that there is a need for a specific enforceable regulation of cryogenic asphyxiants, such as liquid nitrogen, so that companies are required to act where FFG did not.
As a result, the CSB recommended that OSHA promulgate a standard on the prevention and mitigation of hazards arising from the storage, use, and handling of cryogenic asphyxiants like liquid nitrogen, and develop and publish a guidance document for process safety management practices applicable to processes handling compressed gases and cryogenic asphyxiants. Finally, the fifth safety issue found by the CSB at FFG is product stewardship. The owner and operator of a hazardous process is ultimately responsible for the safety of its processes, the facility, and the people who work at the facility. In this situation, Messer owned the Line 4 immersion spiral freezer, as well as the bulk storage tanks that fed liquid nitrogen to the freezer, and they leased the equipment to FFG to operate. When the owner and operator of a process are two different companies, responsibility for safety should be shared. Despite FFG's poor safety practices, Messer had the expertise, ability, and opportunity to take effective action to prevent this incident. The CSB learned that as early as 5 months prior to the incident, Messer discovered and communicated to FFG several safety concerns regarding the freezer. Those concerns were about the risks posed by the freezer's location, inadequate room ventilation, defeated freezer interlocks, and the absence of atmospheric monitoring. But nevertheless, Messer continued to supply FFG with liquid nitrogen despite FFG's failure to correct the issues.
Large industrial gas suppliers, like Messer, are often much more knowledgeable about the hazards of their products than their customers are, as was the case between Messer and FFG. Despite this, and despite Messer's direct knowledge of FFG's unsafe practices, Messer continued its business relationship with FFG. Like FFG, Messer had multiple opportunities to prevent this incident.
Liquid nitrogen and other chemical asphyxiation incidents are preventable. Management must clearly communicate to workers hazards and emergency response measures. Safety management systems for operations that use liquid nitrogen and other asphyxiants must be improved. Doing so can prevent another tragedy like the one that occurred at Foundation Food Group. Thank you for watching this CSB safety video.